So good morning, good afternoon, everyone. Thank you so much for joining us at the Global Alliance on Health and Pollution info sessions. We look forward to your participation and your feedback as to how this platform works. We have an exciting presentation on the complicated chemistry of mercury presented by Dr. Jack Caravanos, who's a longtime friend of ours here at Pure Earth in particular, but he's been doing quite a bit of work in this field. He is currently a professor of global environmental health at New York University's College of Global Public Health, and he works with us at Pure Earth as director of research. He has participated on several of Pure Earth's remediation projects and has provided training and expertise in different countries that we work in related to lead in particular, how to do blood lead level testing, how to do lead remediation, and those sorts of things, advising on those projects. He's originally trained in he's originally trained in chemistry and specializes in assessing environmental contamination. And so we are very pleased to have you with us, Jack, this morning, and looking forward very much to your presentation. As with previous sessions, we will take any questions via the chat box on your GoToMeeting screen. Or if you prefer, you can you can chat Lucy as the organizer if you would like your question to remain anonymous. So just indicate to Lucy if you would like to ask a question of Jack at the end of his presentation. So thanks very much, Jack, and go ahead.
Okay, well, thank you, Lucy and Rachel, for organizing this, and thank you for the invitation. Greetings, everybody. This is a sort of a fascinating element. We deal with many elements at Pure Earth, but none is more complicated, perhaps, than the single element of mercury. And I'm sort of happy to be doing this. It's really very fascinating science here. So why don't we get started? I have many animations, and hopefully they'll appear shortly after I click the button on the screen here. The goals for this presentation, and I have two goals. One is to just appreciate the complex nature of this material, especially with regards to its source and the chemistry and how it moves through the environment, because it's at times a solid, at times a liquid, at times a gas. Then we also have the understanding the chemistry so that we can maybe better improve our sampling and assessments. And this is particularly important for some of the work we do at Pure Earth. Now, the material itself is an ore, and what you see here is a photograph of a Cinnabar mining site. This reddish rock is mercuric sulfide. That's the natural color of it, and it is a fairly high percentage of mercury in it, so that when you heat up that rock, you do get a very high percentage of quicksilver, the metallic mercury. But every now and then, you will see crystals, and sometimes they sell these in stores. So the next time you're at a specialty rock store or jewelry store and you see these crystals that may look like ruby, and they say it's cinnabar, it's almost more than 50% by weight of mercury. The Asians have cut this into very attractive stones in jewelry and are known for their Cinnabar jewelry. Yes, that is mercuric sulfide compressed and made into some very exotic materials. Now, it's a very easy material to work with. Unlike iron and steel and copper, this is actually very, very simple and thought to be one of the earliest mined materials. Essentially, you take the cinnabar, you crush it, and you heat it. It does get a little bit more complicated when you're trying to catch the mercury coming off this. As a matter of fact, we have a problem right now in Indonesia where communities are actually processing their own cinnabar. So mercuric sulfide is a solid, and when you heat it in an oxygen environment, in air, it will react and release mercury as a gas and the toxic material sulfur dioxide. Sulfur dioxide is a respiratory irritant. We don't care about sulfur dioxide. Most people don't collect that. They let it go into the atmosphere. But we do want to catch the mercury. And the mercury vapor coming off this burning just goes right into the air. So you need something to catch it. And there's all sorts of devices out there. Very often this is actually happening in a cement kiln. And what you're looking at now is a classic old retort, which is also used to convert the hot mercury gas into a liquid. Now, as you can imagine, and I've said before, mercury exists in many forms, so let's go through each one. There's inorganic, and of course, there's organic mercury, and none other than metallic mercury, which is something we use in gold mining. So I'll go through each one of these and review some of the basic chemistry um, as simply as I can. These two forms, mercuric oxide and mercuric sulfide, are naturally occurring forms, and they are very high in mercury content. If you look at the weight of this, mercuric sulfide is almost 75% or even more so of just mercury. Then you have other inorganics, and sometimes we call these salts. So when you hear the word mercury salt, this is what they're referring to: mercuric chloride, nitrate, and sulfate, which are soluble. So these powders, when mixed in water or in a lake or in a river, will dissolve, as opposed to these two, which are not soluble. Of course, they're very minutely soluble, but in general, we would say they're insoluble, so they don't really. But here's the sad part: when the two chemicals above are ingested, the stomach acids will make these soluble, so that even though mercuric sulfide as a powder is not soluble in water, when you swallow it and it gets to your stomach, it is converted. This is a very interesting form, mercuric sulfide, and the reason being because you have this company, Chizo Corporation, that used it as a catalyst in making acetaldehyde. And the catalyst, of course, sometimes the mercury went through the process and it produced a very toxic form called organic mercury. You may be saying, what's the point here? This is Minamata. This is what happened at Minamata Bay. The Chizo Corporation, a chemical plant, was using mercury as a catalyst, and the waste products got into the bay, and the rest is history, as they say. So what we have is moving right into inorganic into organic. Since I mentioned Minamata, Minamata disease is primarily due to methylmercury, and there's different types. The X you see there is just a radical, meaning that group to the left can attach to a variety of compounds. So, and many of you may have heard the story of Karen Wetterbaum. Karen Wetterbaum is a Dartmouth professor who, in working as a environmental researcher in toxicology, she inadvertently spilled a few drops, tiny drops of dimethylmercury on her hand. And given that this form of mercury is permeable to latex, she thought she was protecting herself, but in reality, it went right through the latex glove, penetrated her skin in ever tiny quantities, and then proceeded to kill her 10 months later. She got symptoms a few months after the event and progressively got worse and worse and worse, to the point where she's now a very sad history in environmental toxicology. Karen Wetterbaum, and she's a researcher. She was. Many of you have heard of mercurochrome, and mercurochrome is an organic mercury which also contains bromine. It's a topical anesthetic. We don't find it anymore, and is actually no longer available, I think, even worldwide. And this is another form. So I'll talk about the toxicology of each of these briefly at the end. But we have inorganic, organic, and then, of course, we're sort of in love with the metallic mercury, and that's what we call quicksilver. And quicksilver is a liquid. It's a fascinating material. People have been known to just play with this material. It conducts electricity. It flows very easily. It does not really oxidize or evaporate, so it's fairly stable. And you have amazing density. And what you're looking at is a brass weight floating on liquid mercury. It's one of the heaviest metals. Between mercury, lead, and gold, it's one of the heaviest. Many of you know it in that it alloys, meaning it blends with different metals. It's not a chemical reaction, but it is a very strong bond. And whether it's in dental amalgam, you have mercury silver amalgam, as what you see here, or in gold mining, where we mix mercury and gold to, of course, extract the gold. The image you see on the right is what they call mercury flour, and that black material is the ore that is being extracted of gold, and the mercury there has been broken down in such tiny spots that it really doesn't coalesce anymore, meaning it doesn't combine. So you have tiny particles. This is unfortunate because this mercury flour, that mercury has gold in it, but it's very hard to extract it because it's broken up in such tiny little pieces. So later on I'll refer to mercury flour. And of course you have all sorts of devices in history. On the top left, you see a sort of a religious ampule for good luck, for spiritual health. Many people use this all over the country. It's sort of a mystical material. That's mercury and some oil that you just wear around your neck to ward off spirits. And yes, the switches in the original shoes that used to light up were made of mercury, and they were taken out in 1992 thereabouts. Fascinating that the company actually had to go back and pay for the disposal of thousands of sneakers that had little mercury switches so that when you hit your heel on the ground, they would go on or off. There's also a very famous site in Somerville, New Jersey, whereby they're storing mercury because no one's buying it, and it's a government storehouse, thousands and thousands of flasks of mercury, and people just really don't know what to do with it because it can't really be destroyed. So there is a surplus of mercury on the planet. We have more mercury than what we know to do with. So let's go over a very crude mercury cycle, and I do not like this image because it is very, very simplistic. It doesn't even go into the different forms of mercury. You would think that mercury is one material that flows through all these compartments, and of course it's much more complicated than that. And if we look at this image, and I apologize for the quality, you see it does get very complicated very fast. A couple of points on the top left, when you see HG Roman numeral 2, that's inorganic. The HG with the little circle on top is metallic. And then way down on the bottom, in the sludge, let's say, you see CH3HG. This is organic. So what you're seeing is the constant change in chemical states of mercury, going from inorganic to metallic to organic, and back and forth and back and forth. And we'll talk about sort of how this happens in just a few minutes. So the summary here is that we have the powdered inorganic salt, we have the metallic, which we're very used to, and we have the organic material. And this is sort of a better diagram, and I realize there's a lot of chemical symbols, but they're nothing too frightening. I think what I want to focus on in this particular slide is that the conversion from metallic and inorganic to organic, which is the toxic form that killed the professor, is usually happening in sediments in an aqueous solution, water, and it's usually in a hot environment, and it's usually anaerobic. So what I'm saying is this will not happen on the desktop of your lab table. This has to happen with certain bacteria in a warmer climate, organically rich sediment in water. So it's not happening quite as fast as everybody may think it's happening. But it is, of course, occurring worldwide. We'll get back to what parts of the world this is a bigger problem. When it comes to exposure, what we have on the left are the three forms of mercury, and I sort of written some out. And where do you find them? And of course, the first one would be metallic. Liquid mercury is, of course, found. It can be found in soil as a liquid or a coalesced particle, in water to some extent, and also it can evaporate and be found in air. We find a fair amount of metallic mercury as a vapor in the gold mining sites worldwide. The inorganic salts are not quite as prevalent. Inorganic, when metallic mercury lands on, let's say, soil in a warm climate, there will be a chemical reaction slowly converting metallic mercury into inorganic mercury. So think of something as it's rusting. So you put metal on the ground, in a few days it rusts, and next thing you know it's gone. So it's gone from metallic to inorganic. Inorganic things like salt and pepper and powders do not evaporate. So we really don't get a vapor. But you can get a powder, and this is what I believe is happening in Indonesia with the Cinnabar mining, is that people are worried about airborne dust during the Cinnabar processing, the ore processing. Of course, inorganic salts can be in water and soil. And for organic, we find that they can be found in air and water and soil. So here you have one metal in three forms that can be found in three different places. That's 9 different exposure scenarios. Again, 3 forms of the metal in 3 different places, air, water, soil, 9 possible sampling sites. So when someone says, hey, I'd like to sample for mercury, I sort of raise my eyes and say, okay, let's go back a step, because it is a little bit more complicated. So that when you look at a site like this, and which is a gold mining site in Bolivia, it's a hard rock mining site, and you want to sample for mercury, well, in one of these trommels on the top, you could barely see it. It's way on the top in the middle of the screen, a cylindrical vessel. You have liquid mercury. Well, when you have liquid mercury, if we go back a step, you see you have air exposure, water, and soil. So that you have to decide now, am I going to assess the worker, the soil, or liquid that's coming off the process? What you do not have here, is methyl mercury. It is far too cold and hostile of an environment for the bacteria to live that make methyl mercury. So you don't really have this. You'll have inorganic, the powder, and you'll have metallic. But methyl mercury here doesn't really occur. So we do all sorts of sampling, and we have to answer our questions. Are we sampling solids with an XRF, or are we sampling a vapor using a Jerome mercury meter? And that's what we're doing here. And as you can imagine, in something like this wet slurry that comes off the process, the mercury flour is releasing vapor. So you can't quite see the little particles of mercury there because they're so small, but you can appreciate that mercury is coming off this. If you put some of this in your mouth, yes, you would be intoxicated. And of course, some of this is converting to inorganic. By the way, the reading of 2.65 micrograms per cubic meter is above our guidance of 1.0, so this would be considered high. Okay, and some of the intricacies is some people use that sludge to build structures, and we found that some of these bricks and mortar in the villages in Bolivia and Peru are actually made with some of the waste materials from the mining, which still are releasing mercury. And when we go into the house, we actually find that the levels coming off the stone and mortar that contains mercury particles is continuously leaching out. So what you have here, if you could read carefully, 15.66 micrograms of mercury. This is higher than, of course, the outdoor levels. And rather, it was a bit of a shock. So we have to ask ourselves, what is the source of mercury? Where are we going to sample? And various questions about the readings. So going from the chemistry to the air sampling to the exposure assessment, we have to understand what form of mercury we're really interested in. But of course, we do tremendous work in the artisanal community, trying to improve health and safety conditions in this group. And this is a family of artisanal miners, small-scale miners, family miners that are processing leftover material. So if I would ask you what type of mercury do you expect here, you could probably appreciate that you'll have metallic mercury, and the metallic mercury would go into inorganic mercury, but you probably would not have the organic form. So we have inorganic and metallic, but not really organic here. And of course, you see that this is, luckily this is done outside, so the vapors are migrating rather quickly. But we have to assume all the different pathways, because these people are, of course, dirtying their clothes, which has a little mercury flour on there, and bringing it home, and you have all sorts of exposure pathways. Okay, I want to spend just a few minutes on this next set of slides on answering the question, where is my mercury in some of these sites? Because we're often said we're finding no mercury in the mining process. Well, the word mining is a complicated word, and it's usually ore extraction, and you don't need mercury to do this. It's basically blasting away, digging up, collecting the material, excavating it from a mine. So collecting gold-containing ore does not expose you to mercury. Of course, and also loading this material into the processing containers also, if you look at the tables, also has no mercury. The ore is crushed and slides into this trommel, which then mercury is added to that step. And now in these trommels, that big yellow thing, or the small device on the top left, these things are spinning with steel balls, and the balls are crushing this ore. You mix in water and kilograms of mercury. So what's happening is a continuous mixing of the water, the mercury, the ore, the pebbles, the rocks, everything's being crushed, slowly extracting the gold from the material. So you definitely have metallic. Given that this is a rather quick process, I don't suspect much inorganic mercury, and very, very little organic mercury, what's called methyl mercury there, because this would be dependent on where you're doing this. If this is in the Philippines or in Ghana, you would get some methyl mercury perhaps, but in areas like Peru, up in the mountains, you don't really see it. The next step is emptying the trommel, and you could see I'm taking an air reading of the air coming out of the trommel. Yes, it was loaded with mercury, and so is my colleague Yil noticing that. So you do have definitely air exposures, air, water, and soil, and also some inorganic, not really any methyl at this point. The shaker tables, same thing, plenty of metallic mercury vapors in the water, some inorganic. And we have these Peter plates. And at this point, you may have noticed that metallic and inorganic are dominant. As a matter of fact, the real dominant one is metallic, and the dominant phase is the air phase. So what happens here is you're likely. If you're wondering what's going on here, if I may, These are copper sheets, and you could see the copper circles on the one on the left. And you pour mercury on the copper sheets. Mercury bonds to the copper, producing this mirror finish. By the way, this was the original mirrors of medieval times. And then you take your ore that contains gold, rub it on here, and the gold will bond to the shiny mercury layer. At some point, you then scrape the mercury layer off the copper and concentrate it and further process it. So that's what they're doing here. And you can see the marks with their hands as they rub the ore on this. As a matter of fact, in the picture on the left, there's a gentleman pointing to his right. If you look down by his knees, you'll see a white bottle. Let's see if I could do this. Perhaps you could see if my cursor is moving right here. This white bottle is a bottle of mercury. That's how you buy it, a small bottle. Okay. And then there's concentrating of the ore. Yes, you have inorganic and organic, but clearly the most dangerous step is the burning of the amalgam. And this usually happens outside, but we've also found it to happen inside. This also happens in the artisanal community. The commercial ore processors are generally a little better in their practices, but the artisanal are very often not. Though it's nice to see these people are wearing gloves, so that's good. And in the artisanal, we do see a lot of airborne mercury exposure in the metallic form. And this again. And again, notice the picture on the right, the little white bottle of mercury sitting there on the stone. That little white bottle, that's where they get their mercury. And this is, of course, our classic artisanal gold mining amalgam. We are basically concentrating the ore. At some point, we'll add a little mercury to pick up, to amalgamate the gold. And then we squeeze all the excess mercury out. We're left with a silvery ball of material. And then we proceed to burn it. You can see on the bottom right how the color is changing, and getting what is called sponge gold. And this is 40, on average, 40 US per gram. So that's a lot of income for these families. We are very concerned with exposures of different forms of mercury in a home. I think you perhaps were surprised that the levels were so high, and I'm continuously surprised that in the workers' homes we do have exposure to airborne mercury vapors, some inorganic, and possibly methyl mercury, which is very, very serious. Now we do a fair amount of work in throughout the world and different parts of South America, and this is in an area called Madre de Dios. It is the Peruvian Amazon, and we are often asked, where is the mercury? This is a mining site, and it is where they are extracting mercury, gold-containing ore from different layers of the substrata. So they'll scrape off the soil, they'll get this brownish, blackish vein which has the gold in it. And this is what it looks like when it's all done. We've tested this. We've done some clever testing looking for organic mercury, inorganic mercury, metallic mercury, and we find very little, because what they're doing here is actually just collecting the ore. They're not mixing it with mercury at these sites. And as a matter of fact, if you look around, you see really no buildings, nothing, no processing site at all. So mercury contamination, usually the metallic mercury contamination, is a very local sort of event. By the way, what I'm doing here is testing the air in a pit. Obviously testing the surface, winds are greatly affecting it, but if you dig a hole and you let it equilibrate, if there's mercury in the substrata here, subsurface mercury contamination, the vapors would leach out, fill up this space, and we can get a reading. It's mostly a qualitative reading. And we've done this for soil, and we've done this also for water, where we test what they call the headspace. It's not, again, a quantitative, meaning it's hard to go from a air level in the headspace to how much is in the water, but it is very good as a screening. Obviously, if you measure mercury in the headspace of a soil container on the left or a water container on the right, then you have mercury in that sample. So it's pretty good. So we do all sorts of testing, and of course, the first question is, what is it that we're looking for? So this is a vapor coming off an amalgamation step, as opposed to Glenn. He is testing mercury in soil, and this is using an XRF. And some of you may have experience in this. You know that the XRF units, X-ray fluorescent meters, do not really detect very low levels of mercury in soil. It's beyond the level of detection. So don't be frustrated. There's plenty of mercury in the site. We're finding it in the air, but very little in the soil. Another place we do assessments where we have to answer the question, what mercury are we looking for, is the gold shops, the Compra de Oro shops of the world. And essentially, these are servicing artisanal miners. Many miners don't want to burn their own amalgam. They have heard the stories and they don't want to be poisoned, so they bring it to these shops. And these shops are full service shops. This is where they buy their mercury. This is where they buy their tools. This is where they sell their gold amalgam. And they are abundant in various villages in Peru. We've seen over a dozen gold shops in a small village. So very competitive. What's my point here? The artisanal miner will bring their nuggets of amalgam, silver amalgam, the silvery amalgam containing gold. The proprietor will put it into the oven, heat it up with a torch. And what happens is we've tested for mercury here, plenty of mercury in air. This is vapor mercury. This is metallic mercury. And then we've also tested it here, and we found it. But what's interesting is the exhaust vent. If you follow this line, you will see that this is the exhaust vent. And mercury vapor is heavy. It actually will settle out. And we ended up scratching the ground near that motorbike just with our feet. We would just scratch the soil, go down about a centimeter or two. And yes, we found mercury vapors in that soil gas. So it may not be plausible, but mercury vapors in air will settle out, attach to things, and as you know from the household experience, will accumulate. And we've done all sorts of testing in other sites. This is a site in the mountains in Peru. What you have on the left are children, well, teenagers rock and rolling these stones. And these stones are, underneath this stone, you have the ore amalgam, you have mercury, and you have water. And by rocking this stone back and forth, and there's music blaring and they're dancing and having a good time, hours and hours a day, the mercury is mixing with the gold and the ore particles and picking up all the gold. At some point, they stop and they proceed to collect the mercury that's under there. So where would you sample for this, right? You have liquid mercury, metallic mercury, we call it, of course, in step A. And then, of course, this is evaporating, so it's getting into the person's breathing zone. And we've sampled there. Obviously, the gases at point A being generated are very high, and point B is very low. But you could sample anywhere in this area, and because of the slow volatility of mercury or metallic mercury, a liquid mercury, it is fully, wherever you sample, you'll find levels. So everybody thinks the mercury is in step A. However, the air levels throughout this whole community are elevated. And even in the collection pits for the water, they reuse some of this water. And where Brett is standing on the right, our director of operations, all that brown sediment contains mercury. So again, you don't need much liquid mercury to generate vapors. Because this is because this is up in the mountains, we don't see much organic mercury, which is good because that's the very dangerous form. But we do see inorganic mercury, which can get on your hands, on your food, and you could swallow it. So let's maybe sum it up with health effects on this. We have, as I described to you, 3 forms of mercury: metallic, the liquid, inorganic, powder, and organic mercury. In metallic, we can inhale this stuff as a gas, but we could also swallow it either as a gas or as a liquid in water. When we do that, we generally get neurological outcomes because of its form. Now, metallic mercury in your stomach will be converted to inorganic mercury. And inorganic mercury is a powder. It can be ingested. It also can be inhaled as a dust. Just think of when you're cooking with flour, you're inhaling some particles. And that's exactly what's happening here. Inorganic mercury is not really a neurotoxin. It's really a renal toxin, primarily. Renal meaning kidney. So what you have is metallic mercury producing neurological effects, inorganic producing renal effects, and then you have, of course, organic mercury, which is usually ingested, but can be inhaled or dermal. That's why the shading is lighter in those lower boxes. Those are secondary exposures. But as we all know, it's a very serious, different type of neurological effect, and it's called Minamata disease. So this material is moving from compartment to compartment, changing form, sometimes a liquid, sometimes a gas. So it makes its measurement challenging. It makes its exposure assessment challenging. And for a physician, it makes its diagnosis very challenging, depending on the route and the form of exposure. And that's it for the presentation. I hope you learned something about mercury and enjoyed its complex chemistry. It is complex, but we're on top of it, and if you proceed systematically, I think we'll make all the right decisions and actions. Thank you very much.
Thank you so much, Jack. That was absolutely fascinating, especially for someone whose last organic chemistry class was in, oh gosh, a really long time ago. So I'm not going to say exactly how long ago. But absolutely fascinating, and thank you so much for that enlightening presentation, and really helps the audience to understand the various complex forms that mercury can take and how we can measure it and sample it in different situations, and how people can be exposed and what the impacts are. So that's great. Thank you so much. I'd like to open up the floor to questions. I'm sure people will have some, and then I'll close at the end. So let's give at least 5-10 minutes for questions, depending on what we've got, and we'll turn it over to Lucy to moderate any questions.
Okay.
Lucy, did anyone submit questions or ask to be in the queue?
I haven't seen any, no.
Okay. All right. I did have a question, Jack, on the slide for the Peter plates. Were the Peter plates are being used as part of the gold mining process to extract gold from the ore, or was that for tailings? I was a bit unsure.
Good question, and that slide was for tailings. It's very often a last-ditch effort to get the last bit of gold out of the material. And because you know we have that very fine mercury flour. But so when you take this mercury flour containing sediment and rub it on the plates, you get better contact. So people have used it as a primary extraction, but very often it's the tailings that they're going after.
Is that something that you see around the world, or was that just specific to the one place in Peru, I believe it was, that you said you were?
Yeah, that site I believe was in Bolivia, but the answer is I have not seen it. Now I've not been to all the sites in the world, but I've not seen it elsewhere. Not sure why. Maybe it's the copper is expensive, but this particular one was up in the Andes. Yeah.
Mm-hmm. Because my understanding regarding the mercury flour was that most communities had no idea that the mercury flour is being produced and not being captured in that amalgam ball, and that therefore they were losing so much gold to the
Mm,
environment.
yeah.
Mm-hmm.
In our site in Peru, uh, large-scale mining companies would come and collect those tailings and then further process it using the more efficient cyanide process, which is what the big miners do. Cyanide is also toxic, but fortunately it's a very complicated chemical process that artisanal people just don't get involved in. So all those tailings that you see ultimately go on for secondary processing there. Yep.
Okay. Very cool. Is there any other questions from anyone in the audience? If not, I
Yes,
will close the session. Lucy, go ahead.
sorry, there is one question from a member of the audience. The question is, Jack, what about sampling in fish that people eat? How is that done?
Yes, it's a very good question, and it's a better measure sometimes to sample the fish as opposed to the sediment, which can be very variable. Fish, I've done some sampling of organic materials in fish. Fish have fat tissue, which is in the skin and in the organs. They have meat, which is the part that we like to consume, and they also have bones. So when you analyze a fish, it's very complicated. Do you just do the tissue, the meat, or do you do the entire animal? Usually the mercury is going to be found in the fat part of the fish. So when you look at sushi, which is a nice, clean, meaty, fat-free piece of the fish, you won't get as much methylmercury. The thing is, in the Asian community, there's a tendency to eat the entire fish, except the organs, so that you'll eat the skin and the fat tissue, and sometimes even bake the entire fish in soup to get the stock. So I urge caution when you analyze fish. In some ways, you could analyze each of the tissues, the organs separately, the fat tissue separately, and the meat separately. You won't get methylmercury in bone, at least not too much. So it can be. So what we do, to answer your question point blank, you take the entire fish, you put it in a blender with saline solution, you blend it up into a puree, and that's the liquid you sample. It sounds a little gross, but that's that would be total mercury content of the fish.
And is there usually more mercury present in certain types of fish?
Yes, it strongly correlates to the fat of the fish. So the more fat material in the fish, something like bluefish in the U.S. would have more than other fish. The second feature there is predator. Some fish are top of the line predators like swordfish. They eat everything else versus a small fish that is a middle predator.
Okay, thank you.
Jeff.
That is all the questions I had. Rachel, if you.
Okay. As always, you are welcome to submit questions via email to lucy@pureearth.org, Lucie, or to myself, and we can pass them on to Jack. I would like to remind everyone that we are hosting these info sessions every second Thursday, so in 2 weeks we'll have another one. And that one will be actually on pesticides, presented by Dr. Kevin Helps from the UN Environment Program. They are always at the same time with the same link. You can always check our website to find out the latest schedule and who's up next. As well, each presentation is recorded and is made accessible on our YouTube channel, the Pure Earth YouTube channel, because we don't have one for GAHP yet. Otherwise, you can also go to our GAHP website and find the presentations. So thank you all so very much for joining. We are pleased to keep presenting these and look forward to your feedback. So we look forward to seeing you next time. Thank you so much and have a great day.